Today, we're going to talk about one of the most overlooked but high-risk vectors in cybersecurity, file uploads, and how we can transform this risk from a basic compliance checkbox into a true point of confidence for financial services institutions. As cyber threats continue to grow in sophistication, regulatory demands are increasing, and for good reason. Financial institutions handle some of the most sensitive data in the world, and file-based threats are a prime attack vector. Yet, most organizations still rely on outdated scanning tools or limited integrations that barely meet minimum compliance standards. At OPSWAT, we believe that compliance is just the beginning. Through this session, we'll explore how our purpose-built file security solutions not only ensure regulatory alignment, but deliver true operational confidence with deep inspection, zero-day threat prevention, and seamless integration across your infrastructure. Let's dive in. Let's take a quick look at the growing threat of file-borne malware, which is becoming a critical concern for both security and business operations. On the left side of the screen, we see a chart that tracks the total number of malware samples detected annually from 2013 through to 2025. What's immediately clear is the steep upward trend. Back in 2013, we were seeing around 150 million malware samples. Fast forward to 2025, that number has surged past 1.2 billion. That's only a 10 times increase in just over a decade. This exponential growth highlights not only the scale, but also the increasing sophistication and frequency of cyber threats. Now, on the right, we dive deeper into the nature of these threats, specifically the types of file formats being used to deliver malicious artifacts. Executable files, the .exe format, unsurprisingly tops the list at 40%, making them the most common delivery vehicle for malware. But what's more alarming is the growing use of everyday file types like .zip, .pdf, and even Microsoft Office documents like .docx and .xls. These files users interact with daily, making them ideal for social engineering attacks. The takeaway here is that attackers are leveraging familiar file types to bypass defenses and exploit user trust. This calls for a more advanced threat detection, continuous employment education, and layered security strategies to defend against both known and emerging file-borne threat. This slide highlights three of the biggest challenges organizations face when trying to defend against file-borne malware. First, network traffic blind spots. Many traditional network security tools like load balancers, WAFs, and managed file transfer systems weren't designed with file-level threat detection in mind. This creates blind spots where malicious files can slip through undetected. Second, there's a lack of file security capabilities. Even with sophisticated solutions like AI-powered tools, sandboxes, and next-gen firewalls, many threats still bypass defenses, especially those using advanced evasion techniques or zero-day exploits. And third, integration challenges. Implementing strong file security isn't just about the tech, it also involves navigating compatibility, regulatory compliance, cost, and operational complexity. These factors often slow down or even prevent deployment of effective solutions. Together, these challenges make it clear organizations need a more robust, integrated approach to file security to keep up with the evolving threat landscape. This slide outlines key use cases where advanced file security solutions can make a significant impact. Starting on the left, file upload security. It's critical for protecting web applications and networks by inspecting uploaded files from malware before they ever reach your infrastructure. You can stop attacks right at the entry point, especially important for public-facing apps and customer portals. In the center, enterprise secure file transfer and storage addresses the challenge of safely moving business documents within and between organizations, whether it's internal sharing or SRA-protected transfers into air-gapped environments. Ensuring those files are clean prevents lateral spread of malware. Finally, on the right, web traffic security, and SSL inspection. It's about defending against threats downloaded by users. By screening web traffic, especially encrypted traffic, you can catch malicious content before it ever lands on a device or enters your secured network. These use cases show that effective file security must be embedded across all stages of file movement: upload, transfer, and access. This diagram illustrates how file content inspection works at the network perimeter. Files come from users, whether internal or external, are routed through network security devices, but instead of passing them through unchecked, the files are sent to metadata ICAP server, and from there to metadata core for deep inspection. This ensures malware exploits or sensitive data violations are caught before the files reach critical assets like web servers, portals, or data storage. It's a crucial step for enforcing zero trust at the file level. This slide highlights one of the most powerful capabilities in advanced malware prevention: multi-scanning. Using over 30 antivirus vendors, rather than relying on a single vendor's detection method, multi-scanning leverages a diverse set of AV engines from global leaders like McAfee, Bitdefender, ESET, CrowdStrike, Sophos, and many others. Why is this important? Because no single AV engine is perfect. Each has strengths and weaknesses. By combining insights from multiple engines, we dramatically increase detection accuracy and reduce the risk of zero-day or polymorphic threats slipping through. This approach not only improves coverage against known malware, but also offers resiliency against evasion techniques that might bypass individual scammers. It's particularly effective in high security environments where file cleanliness is critical before access or transfer is allowed. Ultimately, multi-scanning gives organizations a layered, redundant defense that ensures files are thoroughly inspected before they ever touch your users, applications, or data. This slide shows real-world examples that highlight the critical importance of multi-scanning and why relying on a single AV engine simply isn't enough. Starting with the top left, November 2015, we see that only 1 out of 43 AV engines detects this particular threat. That means 42 engines missed it entirely, including some well-known names. By February 2016, the same threat was picked up by just 4 engines. Even after months in the wild, detection was still limited. Moving to May 2018, we again see low detection. Only 7 out of 36 engines flagged the threat. That's less than 20%. Finally, July 2024, only 14 out of 26 engines were able to detect the threat, meaning that even some of our top AVs failed to flag it. This underscores how threats can bypass defenses unless you're using a wide and diverse set of scanners. These examples validate the power of multi-scanning. By combining 30+ engines, you significantly improve the odds of catching what others might miss before it becomes a breach. This slide illustrates how deep CDR, or content disarmament reconstruction, plays a vital role in proactive malware prevention. On the left, we see over 150 different types of files entering the system, everything from emails and PDFs to Office docs and archives. Instead of scanning for known signatures or behaviors, Deep CDR takes a zero trust approach. It assumes all active content could be malicious. Inside the process, the file is broken down into its components, and any potential dangerous object, like embedded scripts, macros, or active content, are completely removed or sanitized. Then a clean, fully functional version of the file is rebuilt, preserving the business content but eliminating the threat. That sanitized copy is passed along as safe for use, while the original is either quarantined or discarded, depending on policy. This method is highly effective against zero-day threats and evasive malware because it doesn't rely on detection. It neutralizes the risk by eliminating threats altogether before they can execute. Building on what we discussed in the previous slide, This visual goes deeper into exactly how deep CDR content design reconstruction works at the object level within a file. On the left, you see an incoming file containing a mix of safe and potentially dangerous elements, macros, embedded OLE objects, metadata, videos, and even unused or hidden content. These components are common vectors for malware, especially in phishing attacks or drive-by downloads. As the file enters the deep CDR engine, it undergoes a process called recursive secure file regeneration. Here, every element is carefully inspected. Named dangerous objects like macros or OLE content are completely removed. While other components like metadata, hyperlinks, images, and videos are sanitized or regenerated to remove any hidden threats. The result on the right is a clean, functional, and safe copy that preserves the business utility of the file. Text structure and layout remain intact, but any exploitable elements, the original file, depending on policy, can be quarantined or discarded. This approach doesn't detect threats, it eliminates them proactively, making deep CDR especially effective against zero-day malware and unknown exploits that traditional scanning might miss. Now for a quick live demo. Here we have a basic upload portal here. If I go to select choose a file that I wish to upload, I'm going to choose a particular sort of reverse shell script in PowerShell format. I upload this file, it will go to metadata ICAP server, and ICAP server will send it to core for scanning. So if I click upload, I come over to metadata core, go to processing, and we can see that file is currently in process, and we can see the workflow is via ICAP. If I dive into it, I can see by Metascan, the multi-scanning, I have 8 AV engines here, and only 2 of these AV engines actually detected that this was a malicious piece of code. In particular, one of them actually called out a PowerShell reverse shell script. So we can now see the file has been blocked. If I come over to ICAP, processing histories, again, we can see that this file has also been blocked again. If I go to the upload server, we can see I've got a response that comes back and says, no, your file is not safe. The access has been blocked. This slide emphasizes the versatility of the mesh defender ICAP server, which integrates seamlessly with virtually any network appliance using the lightweight ICAP protocol, a standard for content adaptation. Starting on the left for file uploads, mesh defender ICAP can connect with leading vendors like F5, Fortinet, NGINX, VMware, and NGINX, adding deep file inspection and sanitization before files ever reach your web servers or internal apps. In the file transfer category, you can protect business critical data as it moves across your environment, whether using platforms like MoveIt, IBM, Axway, or Seaburger. The ICAP service scans and sanitizes every file in motion to prevent malware spread. On the right, the file sharing, Mesh Defender integrates with the systems like Dell EMC, FileCloud, and Huawei, ensuring shared content is clean and secure no matter where or how it's accessed. This level of interoperability means you don't need to rip and replace. You can enhance your existing infrastructure with powerful CDR and multi-scanning capabilities. Plug and play via ICAP. This slide outlines the flexibility of deployment options available for Mesh Defender, allowing organizations to implement file security in a way that best fits with their existing infrastructure and future strategy. On the left, we have on-premise via virtual machines, ideal for organizations with a traditional IT environment who want to virtualize their physical servers. This setup supports Metadefender Core, Metadefender ICAP server, and cloud connectors, giving full control within your internal network. At the center, we cater for modern applications like Kubernetes. This option is built for enterprises embracing containerized workloads, distributed apps, and microservices. It enables seamless integration to modern DevOps pipelines while still delivering the same deep file inspection and sanitization capabilities. And finally, on the right, we offer cloud via SaaS, a great fit for businesses with limited IT resources or a preference for cloud-native platforms. you can quickly deploy Mesh Defender ICAP Cloud and cloud connectors without managing infrastructure. Across all three models, whether on-prem, hybrid, or full cloud, you get the same powerful CDR, multi-scanning, and policy enforcement to protect your files wherever they flow. This slide highlights a crucial concept in today's cybersecurity landscape: shared responsibility. Securing data and infrastructure is no longer a task that falls solely on either the vendor or the customer. It's a collective effort. On the left side, we see responsibilities that lie primarily with the organization or customer. These include file upload security, content scanning for malware, stored file security, and customer data protection. Essentially, the customer is responsible for ensuring the integrity and safety of the files they manage, especially at the content level. On the right side, the vendor is accountable for network and infrastructure level protections, like network access management, container and storage security, and enforcement of security policies. They provide the secure environment within which your system operates. And right in the middle, regulatory compliance appears on both sides because it requires collaboration. Vendors must ensure infrastructure supports compliance, while organizations must enforce policies and handle data appropriately. The shared model is key to reducing risk and achieving a strong, sustainable security posture. This slide showcases a real-world implementation of what we call AV as a service. Powered by Mesh Defender Core, it demonstrates how organizations can centralize their antivirus and file security capabilities while still delivering customized protection across different business units. We start with three key concepts at the top. Internal business functions like wealth management, commercial and retail, leveraging a pre-built scanning architecture, avoiding the need to manage security tools independently. Each unit has a customized workflow tailored to its specific use cases. For instance, wealth management unit may prioritize document sanitization, while a retail unit might focus on image and media inspection. All of this operates in a single scalable core of clusters, making the architecture efficient, centrally managed, and easy to scale as demand grows. On the right, you see the Mesh Defender core workflows, where files are processed through multi-layered inspection, multi-scanning, CDR or sanitization, vulnerability assessment, and more. All this happens before files are passed back to the respective business units. AV as a service allows for centralized security control with decentralized usability, and also supports project-level chargebacks and cost allocation, making it both secure and operationally efficient. This quote from Gartner Peer Insights perfectly captures the impact of OPSWAT's file security solution: flawless scanning, zero false positives, and fast performance. It's trusted by leading financial institutions like this one, with up to $3 billion in assets, proving that OPSWAT delivers enterprise-grade protection without compromising speed or accuracy. And with that, I'd like to thank you all for your time and attention today. There's one message to leave you with. It's this: in today's threat landscape, no file can be trusted by default. Threat actors are increasingly using everyday documents as delivery mechanisms, making traditional scanning tools no longer sufficient. With OPSWAT's file security solutions, whether you're scanning uploads, transfers, or stored content, you're not just meeting compliance requirements, you're building true operational confidence. We're here to help you protect what matters most, from the network perimeter to the core, and we look forward to supporting your journey towards a more secure and resilient infrastructure.